Hey, good morning, students, and nice to meet you again. And today we'll be learning regularization, which is a very important family of algorithms, right? And the idea is very simple. You want to prevent overfitting by putting a penalty on something, right? Um, but in the broader context, when you go to deep learning, regularization can be almost anything that prevents overfitting, or maybe it helps making sure that you don't overshoot. Something like batch normalization also is considered as regularization, right? So it has a lot of context into it. So make sure that you pay attention, especially on today's lecture. All these concepts that I'm going to teach actually appears in the modern algorithm as well. So so as we have learned in the class, there are many forms of regularization, and in terms of regression, we can see something like the L2 regularization, in which aside from the normal loss function, we also penalize if the theta gets overly big, which means that you overly depends on certain feature. So this is one case of regularization. So you can imagine that this and this is actually fighting one another, try to balancing off one another to make sure that it does not overfit. On the other hand, we can also have L1 regularization, which is basically based on, instead of the square, we can also do based on the absolute, right? And this and this has very similar effect. The only difference that people observe is that this tends to um, minimize or make the theta of each of the features smaller, but for the L1 liberalization, it has the ability to set certain features theta into zero. So those are probably the major difference. Elastic net is basically the combination of two of this. So you can see that this comes from here, and this one comes from right here. But the lambda is a number that is reciprocal of one another. So if this is a 0.5, then this is 0.5. If this is 0.6, then this will be 0.4, right? So yes, so this is in fact in today's class is the term looks complex, right? But in terms of implementation, it's actually fairly simple. So let us begin. So here I have our previous code of loading the data, scaling features, and adding intercepts. I also have the previous code for the class, in which we have the init function, MSE function, the fit function, the training function, the predict function, the get theta, and get bias function. So we're going to revisit this one again and maybe add a couple of lines, and that's it. And we also have the previous code for testing, which is very simple. So what we're going to do today is something right here, in which we're going to add create a class for regularization, which is fairly easy. All right. So before anything, we have to modify our previous code, in which it contains. All right, so sorry for the pause. Someone just knocked my door. So what we have to do is slightly modify this code, maybe a couple of lines, and that should be good. So what we're gonna do here is, first of all, we have to add a regularization variable here. To make sure that our linear regression is aware that what kind of regularization is it's using. So equal to regularization. And then the next thing we have to do is, give me 1 second. The next thing we have to do is go to the train methods, and we have to change here. So we call that because our loss function changes, now our gradient also change. So what we're gonna do here is basically plus self.regularization dot derivation self.theta. Okay, so please don't worry. Currently, I haven't implemented this yet, but this will be clear. Where does this numbers comes from? So that is that. In fact, actually, I can change the MSE, but because this MSE is mostly for reporting the MSE here, so I will keep it the same. I think the only thing I have to change is the loss function, which in turn change the gradient. All right, great. So that is it. That is it for the regularization for this code. Now, what we have? Okay, let me make sure that I run this code once. So now what we have to do is to implement this regularization code. So firstly, we can do something for lasso first. So we're going to say last lasso, and then self now. And so this is a lambda value equal to L. So this lambda is basically this lambda right here. And so for lasso, we want to initialize it based on this lasso. And then, okay. Right. And the next thing we want to say is that we want to create a function called call. And call is, for those who are not familiar with Python, call allow us to call class as method, right? So, and then this is very handy. So what we're gonna do is whenever you just do lasso bracket, you're gonna return yourself.l times np.sum np.abs theta. All right. So this would return you whenever you call lasso, it will return you this number basically. And then the next thing we want is the derivation, right? This is what I'm talking about that we just add. So theta. So we have to do some derivative here, right? So in this case here, we know that the derivative of our absolute is plus minus. So here we simply return self.l multiplied with np.sine theta. All right. So yep, I think we are done for the lasso regularization. And just give me 1 second to make sure that all the code is correct. Okay, good. The next thing we want to do is we want to, so I can copy this first. And what I want to do is for rich. So for rich, right here will become square. All right. And if you take the derivatives of this in terms of theta, 2 will come down here and lambda multiply theta. So what we're going to have here for the derivation is nothing but 2 times theta. All right. And finally, for elastic, okay, I'm just going to paste the code and then fix it. For elastic, what we're going to do here is elastic. Okay, first of all, let me just fix this rich and this elastic. All right, so here, what we're going to need to do is, aside from the L, we also need the L ratio, right? And this L ratio is basically this number right here. And so we're going to keep that here and making sure that we have self dot now underscore ratio equal to now underscore ratio. And now for the call, we need to have two functions. So L1 equal to self dot L ratio multiply with self dot L times np dot sum np dot abs theta. And L2 is equal to self dot L ratio multiplies with one minus should be one minus self dot L ratio multiplies with self dot L times np dot sum np dot square theta, right? So I think that should be okay. So theta 1 minus theta. I think that should be okay. And here my implementation, I am multiplying the self dot L one more time, so that I have two values, right? First is the ratio, how much I want each of them, and then I also multiply with the L, right? So, and then what I need to do next is now I want to turn the L1 plus L2. For the derivation, L1 equal to self dot L times self dot L ratio times np dot sine theta. And L2 is equal to self dot L times 1 minus self dot L ratio times theta. I guess this should be okay. Maybe I did not do the derivatives correctly because there should be a 2 here, right? But this is all the multiplications, right? So it's fine. So it would be there. And the multiplications will come down here. So actually it should be 2, right? All right, and so hopefully I did the calculations correctly, and then I'm going to say return L1 plus L2, right? All right, so I finished the 3 classes for regularization. So now I want to create a class in which they know all these 3, right? So what I'm going to do here is basically inherit linear regression and call it and has separate classes for them, right? For each of this regularization algorithm. So we can do something like this, very simple. So once we do this, we make sure that this algorithm called lasso now has all the functions in the linear regression. At the same time, we add certain things to it, right? So we can say that def init self method L and L, right? And self dot regularization equal to rich. Sorry, it should be lasso, right? And L. And we just say super init. So the regularization. Oh, and great. So yeah, that's it. And now we have a new class called lasso regression, which can do linear regression plus regularization. So this is a pretty handy. And now we're going to do the same for reach. Right? And we're going to do the same for elastic. I think elastic needs L ratio. Let's give a default. And then if I'm not wrong, I think this should be it. Great. So now we have all the classes and we make sure that they inherit linear regression. Now they can be summoned without we calling the linear regression. Great. So now I think it's time that we try to use our code. So I'm right here. I'm just gonna try one, and that would be why not we just use a lasso regression, and we're gonna say method equal to mini, and LR equal to 0.01, and L is 0.01, and I think that should be it. Give me 1 second. Which only okay. The lasso will need to take the regularization and method. Okay, good. So now just give me 1 second and I will be so regularization equal to match. Give me 1 second, I will be back. All right, so there's one more thing I need to do, and that is the regularization. So the regularization should be actually I don't need this because this is already calling this anyway, right? So I think that's it. That should work, right? And now we call this model, and then we can fit it right away. And hopefully there are no errors. And it say that X train is not defined. So give me 1 second, clear all output. So we start and run on. All right. So I got some errors here. String object cannot be interpreted as integer. So I will fix this real quick and we'll be back. All right, I am back, and so I have realized the problem of this my code has come from actually right here. So here I say cell regularization LR method, which is from the super init. So regularization LR method, but when I goes to my linear regression, I'm actually have regularization LR and num epoch. So the num epochs got changed. So I think what I'm gonna do here is just simply switch here, and the rest it doesn't really matter because I will just use the default value given here. So I think that should be okay. So I clear all the output, restart and run all. All right. So now I have the next problem, that is a lasso regression object has no attribute theta, right? So I will be back again. Give me one pause. All right, I am back, and this is a actually very a simple thing. Before I predict, I must fit my model first. If not, this line of code will not be executed. Otherwise, it can't have the theta, right? So right here, I'm simply putting a fit, and now once it fit, we can predict and calculate MSE, and it comes to that the MSE is at 3064. Let us compare with the previous tutorial how much we got. So in the previous one, what we have is 3147, and the number seems to be mostly higher, a little bit higher. And here we got smaller values, but not in one full, right? So yeah, so that is lasso regression, very, very powerful algorithm, but very easy to, relatively easy to implement. So please try it out and make sure you understand. Okay. Thank you very much and see you next time. Bye-bye.